Greetings. This is a summary of the paper Generalized More Sum Than Different Sets by myself and my colleagues Jeffrey Iyer, Oleg Lazarev, and Liang Zhang. Let A be a finite set of integers and denote by absolute value of A its size. There are two natural sets we can form. The first is the sum set, or the set of all sums of elements in A, and the next is the difference set, the set of all differences of elements in A. We say a set is difference dominated if the difference set is larger than the sum set, balanced if the two have the same size, or sum dominated or a more sum than difference set if there are more sums than differences. Nathanson said that with the right way of counting, the vast majority of sets should be difference dominated. And the reason for this is if you take two generic elements x and y in A, then since addition is commutative, it will generate only one new sum, but since subtraction is not, it will generate two distinct differences. Martin and O'Brien proved that Nathansons intuition was actually wrong if you use the uniform counting of all sets. So if you look at all elements from 1 to n as being equally likely to be in A, then a positive percent of all sets are actually sum dominant in the limit. And numerical and other heuristics suggest that the percentage of sum dominant sets is about 0.00045. Though small, it is non-zero. So how is it possible for a positive percent of sets to be sum dominant? Well, with high probability, whenever you look at possible values in the middle, they will be realized. So for instance, there are many ways to make 10, but very few ways to make 1. And so the trick is to control the fringes. And so some notation for this paper and talk, since we're only going to be adding sets, Ka is going to mean A added to itself K times, and the interval AB will be all integers from A to B inclusive. So the three of the questions we considered in this paper are, can we find a set A such that Ka plus K is greater than K minus Ka, a generalization of the more sum than different sets? Can we find what we'll call a two-generational set so that A plus A is greater than A minus A, and 2A plus 2A is greater than 2A minus 2A? Or more generally, can we find a K-generational set for all K? So the answers to the question are yes for the first and second, but no for the third. No such set exists. So the initial observation is, can we find even one set that is, where Ka plus Ka is greater than Ka minus Ka? And the reason is, once we have one set, we can actually use standard methods to construct infinitely many by inserting things in the middle. Unfortunately, computer simulations were insufficient to find even one set. The probability of such a setting is at most 10 to the minus 8 and almost surely significantly smaller, so brute force approaches don't work. Starting point was to note that if we start with a symmetric set, then it's already balanced. And so perhaps by tweaking this a little bit, especially around the fringes, we could generate a sum dominant set. So for an example of a set where 2A plus 2A is greater than 2A minus 2A is the following. You can see there's a full middle and then slight differences on the two sides. And so the next few slides show what happens as we keep adding A to itself. What's happening is the red dots with the lines between them mean we have all elements from there, and then the blue are the fringes. And as we keep adding, things have been chosen perfectly so that there's one missing sum on the left fringe. When we look at the differences in what happens, it turns out that things are going to be added at such a speed that in the end there will be two differences missing to be compared with just one sum missing. So after dealing with some technical obstructions, we can generalize. And so given any pairs of integers s1, d1, s2, sd2, modulo some trivial things of course, we can find sets A such that s1a minus d1a is greater than s2a minus d2a. So of course, if s1 equals s2 and d1 equals d2, but modulo something like that, or just flipping s1 and d1 around, we can construct such sets like this. So for an example with three sums and a difference losing to three sums beating two sums and a difference is the following set. The next is K-generational sets. So we want to set A so that A is sum dominant as well as A plus A being sum dominant. And such a set exists. Here's an example of one. In fact, we can find a K-generational set for any K, but we cannot find a set that is K-generational for all K simultaneously. No such set exists. And the idea of the proof is we find a specific set AJ, which is going to have JA plus JA greater than JA minus JA, and then we combine the various A's together by using the method of base expansion and separating them out. One last generalization worth mentioning is, again, for non-trivial choices of integers, x, y, w, and z, we can simultaneously solve a lot of comparisons. So for example, we could find a set A such that A plus A beats A minus A, a plus a minus a beats a plus a plus a, etc., etc., etc. Thank you.